Yeah, so we'll discuss one by one of those programs, okay? Right? Okay. Yeah. Yeah. So Alagi, have you completed all the prime number programs? Completed, right? Okay. Yeah. Okay, the first program is print all the prime numbers, right? From the list. Okay. Print all prime numbers from the list. Okay. We'll see how it will work. Okay. So what the thing is like first we'll extract all, one by one prime number. So first step is we'll extract one prime number, one by one number, okay, from the list one by one, and we'll check whether the number is prime or not. How we'll check, guys? Shimuki, how can we check whether a number is prime or not? Hmm. Yeah. See, it should have two factors, right? If the number is wanted to be prime, it should have only how many factors? Two factors, right? Yeah. Fine. Let us see that. Okay. So first we'll take one list and we'll try to filter out all the prime numbers from the list. Okay. Right. 10, 23, 45, 60. Shit. Eight 30, yeah, why? Basically, our class at 8 only, right? 8 or 8, 10, na? In between only. You forgot, huh? No, no. Okay. No problem, no problem. Okay, based on some days gap, now you might be forgotten. Okay. So, can you see my screen right now? See, the first point is we'll extract one by one the numbers, and second point is we'll check whether a number is prime or not. How we'll check means we'll calculate the total factors for each number. Okay. Then if the count of factors equal to 2, then it's a prime number, right? Hmm? Okay, let us try that code. Okay. We'll just wantedly add some prime numbers. 57 is a prime number. 37 is a prime number. 60 is non-prime, right? So what we'll do for x in Li. Okay. So one by one, each number will come to x. Okay. First the x will be 10, then x will be 23, x will be 45, like that. Okay. Clear? So if I want to check whether the x is prime or not, how many factors means two. Okay, if the x having exactly two factors, it's a prime number. Okay, so to check, okay, whether x is having a factors or not, from where to where I should divide. I should divide from one to till x. Okay, clear? For I in range of 1 to x plus 1, right? Because I want to divide every number with x till x. Okay, you got it, right? If x modulus I double equal to 0, count plus plus. Guys, is that clear? What I'm trying to write? Huh? See, I'll tell you. See, what happened is first that this 10 will be coming to x. Okay. Once the 10 is coming to x, now this x will be constant. Okay. The x is not varying. Okay. Now this it will wait for the next iteration till this loop is getting completed. Okay. You got it? So for x equal to 10, it will make sure the whole loop is completed for x equal to 10. So we are making our I, should travel from 1 to 10, right? Because 10 plus 1, 11, right? So it will be inclusive, na? Sorry, exclusive, right? 1 to 10 only. You guys, is that clear? Yeah, yeah, yeah. Yeah. So if my x is 10, we are traversing from 1 to 10 plus 1, that is 11. So 1 to 10. If my x is 23, we are traversing from 1 to 23 plus 1, that is 1 to 23 only, right? Aliki, are you clear with this? I think yesterday, day before yesterday, I told you, right? This logic only. Yeah, yeah. So now we clear, right, Aliki? So the thing is, my internal loop will be keep on iterating, but my x value is constant. When will my x value will change? Once the internal loop is done and the below statements are done, then it will go to top, and then my x value will be constant changing, right? Clear? Huh? Got it? If my count equal to 2, then my x is a prime number, right? X is a prime number. Okay, clear? Yeah. Guys, is this program is right? Do you find any issues, potential issues? Sorry? Count should be? Uh-huh. That is fine. I'll add. Is this program is right now? At least you tell me. Tell me. Is program? It will? See, suppose, let us assume how many factors for 10 guys? For 10, we have 1, 2, 5. Am I correct? And 10. So my count will be 4. Okay. And this is my 10 is not a prime number. Am I correct? See, if you take 10, yeah, yeah, that's what I'm trying. I'm just expecting 1, 2, 5, and 10 for 10 factors, right? So here the count value will be 4. So it is not satisfying. Okay, fine. Now it will go up. My next will be 23 now. But 23 is supposed to be prime only. But my count value, my previous count value is 4. Okay, that will add up. Okay, to the next number count. Guys, you got it. What I'm trying to say. The previous number count of factors will add up to the next number count of factors. So Srimuki, can you got this point? Did you got this point? No, okay. Surprising. Okay, fine, fine. Alike, you? I'll, I'll, I'll explain again, okay? Please do. This is a major logic stream, okay? I thought you can, but no problem. 10, 23, no, 57, 60. Let's assume 80, okay? So first my x will be 10, right? So we are counting factors from 1 to 10. Okay, 1 to 10 plus 1, 11. That means it will be dividing x with all numbers from 1 to 10. Am I correct? So here, each time, whenever I got a factor, each time my count will be increasing. So my total count will be 4 in this total loop. Okay, na? In this total loop, my total count will be 4, right? So after that, what I'm checking if my count is 2 or not to check for a prime number. Am I correct? So definitely my count is 4, which is not satisfying. 4 not equal to 2. So definitely my if loop will be won't be executing. I won't be printing that number. Am I correct? Now, if I take after the completion of this all the statements, it will go for the again for the top one. Am I correct? So now my x will be 23. Now, if my previous count, already my count is already 4. Okay. So definitely for 23, the factors are, 2 only. But my previous count is there now 4. So my total factors will be 4 plus 2, 6. You got it right? The logic is going wrong. Yes, yes, that's what I was expecting. Okay. So you should write, count should be refreshed. Correct, exactly. So every number before starting, you just make count equal to 0. Okay, clear? That's it. Done, right? Ali, are you fine now? Yeah. See, 23 is a prime number, 37 is a prime number. Okay. Guys, I expect you guys to do this, but okay, unfortunately. Huh? Can I give? Apart from zero, apart from zero, you want me to give some other counter? Is it like that? Uh-huh. Yeah. Else, if you write else, na, it will for every number it will check. Yeah, yeah, correct, correct. Prime, not prime, like that it will print. Correct, only good logic. It's a good logic only, Srimuki. Like it will check like okay, prime, not prime, prime, not like that it will come. Okay. Correct. Yes, yes, yes. Okay. Aleki, how you find now? See what she's asking. If I write else, okay, for each number it will check prime, not prime. But we want only primes. We don't want to be our console to be printed with non-prime numbers. Okay, that's what. Okay, clear. Fine, right, Aleki. Okay. Guys, after my classes, how much you are analyzing, that will, make you strong in coding. It's not like if I'm teaching and you are listening and, you'll feel you guys are getting understanding, but it's not the same. Okay. After the class, you try to analyze whatever the logic I have told now so that it will be, imprinted, it will be registered more into your mind. Okay. Clear. Because this is what I experienced. Okay. In my college days. That's what I was trying to say. Okay. Clear. Okay. Okay. Right. Now the thing is, I want to print all Armstrong numbers from the list. The same logic, by the way. Just you need to change the prime number logic to Armstrong numbers. Okay. See, guys, I'm not giving any time to think for you because we are already a little bit 10 minutes. Okay. Right. Program is print all Armstrong numbers. Okay, guys. At least you tell me the logic on a high level. Like you tell me like. Uh, Armstrong number logic is fine. Just tell me what is the on a high level logic. Like first, we'll fetch each number to x. Am I correct? First, we will fetch each value to x. Then, then we'll apply. Then we'll check whether the x is Armstrong or not. Okay, am I correct? Check. So, Aleki, can you tell me what is the logic to check Armstrong number? For suppose if x is an individual element, how can I check whether the number is an Armstrong or not? Can you tell me in a few lines on a high level? Okay, so that will fetch the last digit. Okay, then we'll cube that number now. Like because assuming the number having three digits, yeah, we'll cube that number and add it to the sum. Am I correct? Okay, then we'll remove the last digit by dividing by 10. First, we'll do modulus 10, fetching the number, cubing the number, and adding it to the sum and removing the number, right? Let's sum. Yes, yes, yes. Super, super. Correct. See, first we'll fetch remainder. Yeah. First we'll modulus 10. Yeah, correct. Yeah, yeah, correct. So, yeah, yeah, that is also good, 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 good. Yeah. Cube equal to remainder. Yes, yes, yes. Super, like, yeah. You're getting progress a lot from day one to now. Yeah, good, good. Okay, sum equal to sum plus sum cube. Okay. Okay, then num equal to, come on, num by 10. Okay, clear? That's it. This process should happen till my num is, yeah, yeah, that, yes, 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 super, super. Correct, correct. Exactly right. Right, let's write that. Shimuka, are you clear, right, at your end? Okay, see, I know only Armstrong number 153 only. We'll add that and we'll check if she's printing or not. Okay, right? So, 370, yeah? Thank you. Okay, okay. Let us try both the numbers. Okay. Here it is a time, in my home. I was in my home. My brother kids are going to school now. They are making hurry burry. Okay, come on. While see x not equal to 0, see remainder equal to x modulus 10, sum equal to sum plus remainder clear. X equal to x by 10. Okay, guys, see. And what I told is you take a variable called temp and store this x into the temp. Okay, so that after while loop you need to check with the sum with the temp. Okay, not sum with the x. Am I clear, guys? If if sum double equal to temp, not x, guys. Okay, people will often confuse here. Okay, they'll fall in the wrong logic here only. Okay, so you should write temp is Armstrong number. Okay, clear? Huh? Guys, these programs you should do. So why are you making me to do? Okay, fine, but anyway, actually, okay. I thought Srimad will complete this, but disappointed. Okay, no problem, Srimati, no problem. Why it's giving me error? Remainder. Correct one, na? Actually, sum I have not initialized, na? Okay, see guys, again, my sum should be 0 every time. My sum should be refreshed because if I'm not refreshing the sum, the previous sum will add up to the next number sum. So unfortunately, it will be mess. Okay, clear? The same logic, how we done for the prime number, now we are refreshing the count, right? Here we need to refresh the sum. Okay, clear? Guys, why? Why here? See, my sum is 0 and x not equal to 0 and I'm fetching the digit and I'm adding it to the sum and x equal to x by 10. Okay. Uh, but why I'm not getting any number here? Yes, where are we gone wrong, guys? Anyone? Sum with temp only, right? I'm comparing. My x is anyway is going to 0. So that's why I'm storing the x value in temp. Uh, sorry, sir. Uh, no. See, after the while loop only, right, we need to compare. If I write if I means it is not a good logic, right? Because it's not a right. Because after the while loop, we are calculating sum, then we are comparing sum with temp. It is supposed to be outside the while loop only. Okay, where we are gone wrong, guys. No, see, for every iteration, when my sum will go on 0. Okay, just let me rerun again. I think is the mistake here. See, 153 is an Armstrong number, right? It's supposed to be here. Did you miss something here? M equal to x mod 10 and sum equal to sum plus remainder and x equal to x by 10. Yeah, it's a floor division, guys. Sorry, it's a floor division. Yeah, I usually write Java. Okay, it's a floor division. Yeah, see, because this normal division will give you in fractions, so it will be a mess. Okay, so write the floor division. Okay, otherwise you will be gone wrong. Okay, see, Shimuki, three numbers are Armstrong numbers. Okay, okay, clear, guys. Don't go with normal division. It's a floor division. Okay. Shimik, I think we already faced this problem earlier. Okay, right? Earlier. Correct, correct, correct. Okay, okay, okay. Next problem. Any more programs, guys? On that day, what are the programs we give apart from these two? Perfect squares, right? All the numbers are how many perfect squares are? Okay, fine, fine. Okay. So perfect square means what, guys? It is a product of two numbers, right? 25, 36. Am I correct? 49. These are the perfect squares, right? How can we, justify whether a number is perfect square or not? That's the logic, right? Am I correct? Hmm. So how can we do, guys? Anyone? Come on. Okay. Square root. Yeah, think, guys. Now you think. Okay. Think and tell me. Just take a 3 minutes of time. It's a new problem, right? Because we haven't discussed this perfect square program earlier. It's very easy logic, but you should use, I'll give you a clue also. Use square root function, okay? Yes, correct, 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 correct. Yeah. Yeah, yeah. You should use the math library. That's the clue I gave. Okay, I'll be waiting for 2 more minutes, then I'll write the code. Okay, clear? Yeah. Guys, we have 2 days of time and I gave you this work. You're supposed to do right. Okay. But what you guys done? Guys? Yesterday also I haven't taken class, right? If you remember. You're supposed to complete it. Actually, I thought this would be the last class for list. Okay, but again, I will take one more class for list. Okay. After list, we'll start with the thing, the tuple. Okay. Tuple will take 2 days only. It's not a big chapter, small chapter only. Small chapter only. Okay. Yes, please go on mute. Please go on mute. Please go on mute. Because we are recording the session, right? Okay, it will be disturbance for the guys who are watching online. Okay, guys, the time is up. Let me write the code. Okay. See, what is the logic means? Very simple. See, I hope you guys can do this, but okay, no problem. See, suppose if you take a number 4, Shrimuki, can you see this? 25, 30, 37. So if you write m dot square root of 2, 4, right? So this will be 2. So 2 into 2 will become 4 only, right? See, each time we need to typecast int, okay, for each value, okay. Now if you take 30, 30 means, okay, if you write m dot square root of 30, okay. Guys, can you tell me the value of this? Anyone? Guys, come on. And then we need to typecast this upcoming value. See, guys, what is the value of this approximately? See, 5 point some fraction, right? 5.1617 something. Okay, let it be. Okay, clear? Or 5.4, okay, something. Okay. If you convert to int, it will be 5 only, right? Okay, so the 5 into 5 is not 36, it is 25. So it is not a perfect square. Am I correct? Very simple, right? What I mean to say, if it is a non-perfect square, it will give you in fractions. Okay, suppose that if it is 30 now, it will give you 5 point something. Okay, okay, na? Right. So that 5 point something will be converted to 5 only at the end of the day. So it is not a perfect square, right? Because 5 into 5, 25, 25 is not equal to 30. It's not a perfect square. Guys, is that clear? The logic. Oh, really? Yeah, you can ping in the chat box. Yeah, it will be a bit large. I think it need to do some more iterations. Okay, fine, no problem. We'll try that as well. Okay. Yeah, if you're able to do without using this square root functions, it will be better or more better. Okay, because the interviewer will be more impressed. Okay. Oh, this guy is writing actual logic, something like that, right? Alekya, are you able to understand, Alekya? See, just import this. I told you earlier, import math as m. Okay. Now call m dot square root. Okay, m dot sqrt. Okay. See, Alekya. Okay. If okay, if what is that? Come on. S equal to m dot sqrt of x. Okay. You should typecast to int because if it's the perfect square means okay. But if it's not a perfect square, it will give in fractions, right? It will 30. It will give 5.4 something, okay? But it will typecast, you need to typecast to 5, okay? Am I correct? Okay. If s into s equal to x, then my x is a perfect square, right? See guys, 25 is a perfect square, 36 is a perfect square, right? Okay, fine. Okay. Shivuk, you said you wrote some logic. Can you ping in the chat box? No, no, it is no use. Just it's for previous program only. You can remove that. Okay. It's a good doubt, but yeah, it's a waste variable only, right? If you're not using the variable, just remove them. Okay. It will be good, more sense. Okay. It will be making more sense, right? So you wrote Srimuki for num greater than 0. Yeah, it is like num power of 0.5. That means it's a square root only. Yeah, it's a good logic, by the way. The square root function internally will do the same thing, right, Srimuki? But we are using, see, obviously, yeah, correct. But again, it's a good logic only. Num power of, see, the Alekia, these two stars are there, no? It will acting like a power, okay? In Python, this two stars operator will act like a power. And if suppose num means 4, na, 4 power of 2 means 16, or 6 power of 2 means 36. But here 0.5 means it will be 1 by 2. This will be a square root, right? Right, Shimuki? That's what your intention, right? Yeah, that's a good logic, by the way. Okay, then, yeah, by same thing, okay? Alek, do you have any doubts in this code as well? I'll paste this. Yeah, like just instead of having the square root function, internally the num power of 0.5 will be a square root function only, right? And you typecast into int. Okay. See what I'm trying to say, whatever this m dot square root of x is doing internally in this function, this num power 0.5 is doing the same thing. Okay. Suppose Alekya. See num power of 3. How much this value? 64. 2 power of 5. This is 32. Okay, clear. Like that. Okay. Okay. And see here we are printing the numbers each time, and Shimuki has taken one empty list and she is appending all those numbers to the list. Okay. Did you find some difference, like now, to our program and Shimuki program? Yeah. So in n number of cases, you can find n number of things. Okay. So it is also the same only. Here we are printing this. Shimuki is appending to an empty list. See, ps dot append of num, ps dot append of num. Each perfect square, she's appending to the list, and she should print. Actually, she forgot to print of ps. Okay. Fine, Shimuki. See, what Shimuk is doing, she took one empty list and she's appending all the perfect squares into that list. And she is printing at the last. But we are just finding the perfect square and printing instantly. Okay. Okay. Yeah. In this way, you need to understand logics. The same logic can be written in n number of ways. Okay. You need to understand all the logic so that, according to the situation, you'll act. Okay. Right? You don't know how the interviewer will ask. Okay. You don't know how the project, requirements. So the thing is, you need to understand n number of solutions, right? But logic is same anyway. Okay. Right. You can see, guys, all the solutions after the class. Okay. Guys, any more programs? I think enough, right? For today. Programs. Anyway, if I miss here and there, you just try. Based on this knowledge, you can try. Okay. Right. Okay, guys, I want to stop here, and tomorrow we'll see the last part of list. Okay, because I don't want to start list functions now again. Okay. Right. Clear. And yeah. Okay, fine. Yes. Okay, we'll see you tomorrow. Okay. Clear. Bye bye.